The input optic to a spectral radiometer defines the geometry over which measurements are performed. Here we are concerned with two measurements, that of spectral irradiance and spectral radiance. There is an additional optional measurement which we term spectral check, and this is merely a manner of using the IDR300 over its maximum spectral range in a DC configuration and with maximum throughput to determine the emission regions of a source, and on this information one can decide where one should perform more accurate measurements. The measurement of irradiance is performed using the D7 cosine corrected input optic with light coupled to the monochromator using the FOP UV quartz fibre bundle. The round ferrule end of the fibre bundle attaches to the rear of the D7 diffuser and is held in place using a grub screw. A threaded M6 mounting point is provided to be able to mount the diffuser on an optical bench. The FOP UV fibre bundle is composed of a very large number of discrete fibres. The fibres are clearly fragile. We recommend a bend radius no less than 100 millimeters, and that in laying out the fibre, mechanical stress be minimized. To inspect the condition of the fibre, one can hold one end of the fibre to a light source and look at the other end. One would expect to see a large number of individual fibres with a small proportion black or broken fibres. That's perfectly normal. Where a large number of fibres are black, then clearly the fibre is damaged and should not be used. The measurement of spectral radiance can be performed either as an irradiance measurement with an aperture at the source to define the field of view, or as a radiance measurement directly using a telescope. The telescope acts in a similar manner to the eye. A lens images the source onto a plane. In the case here, the plane consists of an aperture wheel with a very large number of apertures to allow selection of the field of view of measurement. The telescope has been designed for use from 200 millimeters to any 500 lux distance. So 2 points to note there. Firstly, we have two lenses to cover the full range. One called close-up, which does from 200 to 400 millimeters, and one called distance, which covers the remainder of the range. And one can simply screw the lens on and off the front of the telescope. A small aperture disc with a 7mm aperture is provided, and this is really only used to attenuate the signal on the CMOS camera during the alignment, else the camera is in overload and one cannot see an image of the source. As the measurement distance changes, the distance to the image plane changes. And given that the image plane is fixed here, we use a periscope to adjust for changes in the image distance. And this periscope is driven by a stepping motor, and one can hear that run as the telescope runs. The TEL-309 allows measurements over two fields of view, 11 and 1.7 milliradians, and light passing through the aperture relative to those fields of view is coupled to a fibre which is attached using 3 M2.5 screws to the IDR300. It is useful to note the reason for the short fibre. The measurement of radiance is required over the range 300 to 1400 nanometers. In order to perform measurements to 300 nanometers, one must use quartz as opposed to glass, which attenuates light below 350 nanometers. In the production of quartz, water is added, and this presents a hydroxyl OH- group absorption at 1380 nanometers, just before our limit of 1400 nanometers. The shorter the fibre, the less the attenuation, and it's for this reason that a short fibre is employed. The telescope has to the rear a USB input, and it has its own power supply which adapts to the bottom and is controlled through Bemmen Plus. Finally, the SpectralCheck optic resembles very much the D7 diffuser without the diffusing element. In fact, it's merely used to provide a nice manner of adapting to the calibration lamp to calibrate in SpectralCheck. The diffuser, as is the nature of the measurement, reflects 99% of the light, so very little light is transmitted to the monochromator. In attaching the SpectralCheck optic to the fibre, no modification of the field of view of the fibre is affected. The fibre has a view of some 20 degrees cone angle, and that is what is measured of the source. The geometry isn't important here, since we really only want to measure where light is emitted. The SpectralCheck is useful for determining indeed where light is emitted, need one measure in the UV, in the infrared, and it's also useful in evaluation to the EU Energy Related Products Directive, where very, very low values of UVC are to be measured against Directive 244.